يعطيك العافية. خلينا نتابع اللكتشر الميكسرز وعدد كنا أعطيكم أمثلة على الميكسر. خلينا نبلش بأول مثال على الميكسر. لو كان عندنا السيركت زي السيركت الموجودة كالتالي: كريزيستنس مع طبعا single balance mixer is giving us as this is an M1, this is M2, and this is the V output, and this is what we call the R of D. This is VDD. Select this one as VRF, and we select this one as VLocal oscillator. بالنسبة إن as we agreed together إنه VLocal oscillator أو local oscillator wave has a 50% duty cycle. Okay, and assume we have long channel modulation for transistor and lambda is equal 0. Okay, so G of D is equal 0. Okay, first we need to find first question I can ask you about assume that M1 is an ideal. M1 is an ideal switch. Determine all frequency components. Okay, so if you think about the frequency components, you're gonna say, the frequency component signals, you can find it by, first of all, we have a square wave, the VLocal oscillator, we have it as, and I assumed it's 0 and 150 cycle percent. So I local oscillator of T is equal half. This is the Fourier series of it. If you it is half plus 2 over pi la cosine W local oscillator of T minus 2 over 3 pi cosine 3 omega local oscillator of T plus etc. Okay, now the IRF of T, as I told you before, it's almost equal I bias. It is a DC or I bias plus IRF with a cosine omega RF of T. So now the intermediate current or intermediate frequency current is equal I local oscillator of T في IF of T of T. Okay, and this is giving us what? This is giving us I intermediate frequency of T is equal half plus 2 over pi cosine W local oscillator of T, and this is plus etc. because we didn't need the higher harmonics multiplied with IDC أو I bias plus IRF في cosine WRF of T. Then we have the formula. It is equivalent to I bias over 2 over 2, okay, plus 2 I bias over pi cosine W local oscillator of T plus IRF over 2 cosine WRF of T plus IRF over pi في cosine WRF minus the local oscillator of T plus cosine WRF plus W local oscillator of T. And this is what we called, the intermediate frequency positive, and this is the positive, and this is the intermediate frequency. Now this is to be filtered. We're gonna filter it out, okay, and this is what we have, intermediate frequency. This is the signals as the RF feed through. This is what we called RF feed through, okay, and this is the signal we called it local oscillator feed through. And this is what we call the DC components. So we have the first term, it is a DC component. Second term, it is the local oscillator feed through. And please keep in mind the feed through. If I ask you to find the feed through, this is how you're gonna find it. Then we have RF feed through as well, components. Then we will have an intermediate frequency components. At all. The positive one, it will be filtered out, so it is ignored. Okay, this is the components this is what we called all the frequency component which appear at the mixer port. So, and the mixer or intermediate frequency ports, you will find this is. And I use the current specific because we didn't ask about the gain so far. Now, if we assume, let us assume that if we assume M1 is on, M1 is on, so it has on resistance of R1 number. طبعا find the voltage conversion, okay, gain of the circuit so we have the resistance, we have it over here, we have it over here, and we have V local oscillator, and we have VRF, and we have, this is what we call V intermediate frequency, and we have this is as VRD. Now this is an M1 and this is M2. I'm saying إنه الM1 is an ideal وإنه بعطيني resistance مقدارها ال R1 is equal R1. اوكي لما يكون انه switch on راح يعطيني resistance بمقدار ال R on. First, as you know, we can find from the previous one, if you think about it, if you want to find the ideal, if we take it an ideal way, like if we have this without losing any generality, we have this one. If this is a local oscillator and this is VRF and this is VIF, okay, we have as following. I told you VIF is equal RD في IIF في of T. Okay, we have it over here. We computed the IIF as we need these terms just so. But IIF is equal IRF في ال I local oscillator of T. Okay, the IRF is equal, assuming the IRF is equal GM whatsoever GM في VRF, which is GM ARF في cosine WRF of T, and we have local oscillator. If we have it here, we have the local oscillator as half I local oscillator 50%. We have an I local oscillator is equal half plus 2 over pi cosine W local oscillator of T plus blah blah, etc. It is coming as VIF of T is GM في ال A في 2 over pi cosine WRF of T cosine W local oscillator of T. هاي المتباينة الجميع بعرف حلها، فبتصفي عنا مضروبة في ال RD طبعا. اوكي، فال VIF here of T is equal half, it will be GM في ال ARD over pi cosine WRF minus WRF local oscillator. Sorry, so it gives you WRF minus W local oscillator of T plus cosine WRF plus W local oscillator of T. This is the summation is going to filter out. So we have converging gain, conversion is equal GM في RD over pi. Now, I ask you to solve the problems when M1 is generated at the R on. So we have this one. So if M1 is given us R 1 when it is on. So we have as this one V local oscillator, V R up, and this is what we call the intermediate frequency, and this is the RD. Okay, now as we saying here, we have this one over here. Okay, so from my point of sight, as I told you before, delta ID is equal GM في VRF. Okay, now we have this is as NMOS, this is NMOS plus GD في delta VIF minus GM plus GD, okay, VX. If we want to solve it as it is, we take delta ID. Now, delta ID is equal what? Minus, okay, minus VIF, delta VIF over R of D is equal GM في delta VRF. This is going to be 0. VD is equal 0. We have minus GM في delta VX. But we have delta VX is equal delta ID with R on. Okay, so that delta VX is equal minus delta VIF over RD في R on منه as equations, it's coming as minus delta VIF over RD is equal GM في delta VRF minus plus GM في delta VIF over RD بالR on. Okay, so VI delta VIF over delta VRF is equal GM over في RD في 1 plus, this is a minus 1 plus GM في R on. Okay, so this is what we call the gain for the system. So if we want to find converging gain, let's say converging gain, okay, it was GM في R of D over by. Now the converging gain at R on 1 for M1, converging gain is equal 1 over by في GM في R of D over 1 plus GM في R on. Okay, so just this is the what happens for the signal. هسه إذا بدنا نصعب الأمور شوية، إذا سألنا what's noise? What's the noise figure of the mixer. If we ask you what's the noise figure for the mixer, a noise figure for the mixer is giving as طبعا هنا assume M1 is an ideal, so the contribution noise, so it is noise free. Okay, so we have noise coming from the RD and noise coming from M2 transistor, and for the noise for M1 we don't have a noise here, noise free. This is the VRF, so we're gonna find it. So we have for this example, noise sources are M2 and R of S and R of D. So we have three sources of noise. We have V and out. M of T is giving us as what? RD square it is GM في ال RD square it is AV square في ال V drain gate square. The V noise drain gate square is equal to 4KT lambda over GM. The AV, as you know, it is GM في R of D. So the V output, the V noise output, the M2 is given as 4KT sigma GM square للRD square. GM في الRD square. Okay, this is for the first source. For this, the RS, now to the RS source, it is giving us as AV, V output noise, the R source square is equal to AV square with V noise, the R of S square. This is giving as 4KTRS, and this is giving GM في R of D equal square. Now for the noise, third noise, it's coming from the RD. It is giving us V output noise RD square. It is V noise RD. It is the same as it is, and it's giving 4KT R of D. Now, a number of whiteboards. Now we have the F, and this F is going to be 1 plus noise of M1 and R of D over noise of R source. Okay, so you can try it at home and you will get it only. واضح. ناخذ مثال مش عارف أقدر أجيب أتوقع هيك تقريبا غطينا كل المادي يعني بالمكسر. بس بدك تتدرب وتاخذ in your consideration that إنه السيركت ممكن أنا يختلف فيها بعض الأشياء، فلذلك لازم بس تتدرب على السيركت اللي موجودة عندك. يعطيك العافية وشكرا.